In this video, I'm going to cover the mirror field problem. Okay, so hopefully I've read through the problem. This specifies the size of the input and the mirror positions. I'm going to draw that. This is an interesting problem. Basically, we understand what's going on, but kind of how to convert that into code is the question. Right, so I'm just going to draw this picture. These are the mirror positions. So these are the mirror positions. So what it's asking is what is the maximum number of reflections it can have, right? So for example, if you kind of come and hit the mirror like this, it's going to reflect here. Similarly, opposite direction too. I'm not going to draw the opposite direction because we know it's a it will happen exactly, right? So for example, here it's going to reflect here and get out this way. So this is just one reflection. Here there are two reflections, right? So how about here? 3 reflection, right? Got out that way. And for example, if you hit here, so 2 reflections, and that's 1 reflection. Anything else we missed? Here 1 reflection, that's it. So basically you have to look at it from all the angles, okay, all the directions rather. Okay, so how are we going to code this? So beyond it is really details on how we are translating this into code. That's what this is. I'm going to do it in C++, but I'm going to kind of explain Java along the way. Okay, so hopefully it will work. I just copied the template file and made it as a mirrors, and okay, so we need that array. So the one thing you can do, C++, it's kind of messy to do 2-dimensional dynamic array, whereas Java it's pretty easy. So I will kind of mention both. Okay, let's take care of the mundane stuff. Okay, so C++, I'm going to keep this as a global variable. In Java you can keep it as a kind of within the class static or something like the static int. We can do that in Java. So the array is going to be character array, mirrors or positions, or what do we want to call it? Here mirrors is fine. If you can come up with better name, that's fine too. So maximum is 1000 mirrors, right? Maximum is 1000. So we can define something as a maximum. Constant into max equal to 1000, and okay. So we are defining the maximum size, but we are going to use only whatever we need. Okay, that's the easiest in C++. In Java, what you can do is, okay, as soon as I put comment, all this becomes messy. Okay, so in Java, what you can do is within the class you can do static integer num and character mirrors like that, right? So then you can I guess that is also probably static. Later in the code, within the main, you can code like mirrors equal to, after reading that num variables, new int n m. Okay, you can do that in Java. Okay, so I'm just put this in comment. It may be hard to see once I put in comment. I'll try to fix that sometime later. Okay, so you can do something like that in Java. And now what, until I finish coding, at least I can leave it as it is, right? Okay. I know that's a bit confusing. There's a Java code there, then this is the C++ code. Okay. Just wondering, I can quickly fix that. If we can fix that, that would be good. C++, coloring, highlighting. Not very easy, looks like. What is this? Default code, syntax, highlighting, comment, normal. Yeah, that's what the problem is. Comment, foreground. There you go. That fixed it. Default. For now, that's good enough. Okay, now I can comment this out without really worrying. Okay, now at least you can see the code. Very good. So let's go back here. Now it's time to read all this stuff. Fn n, basically rows and columns. If you want to do rows and columns, that's fine too. N is the rows, m is the columns. So then read the array, I less than n, I plus plus, j less than m, j plus plus. C++ is very easy reading wise, and it makes it so much easier. Mirrors of ij. You cannot do this in Java. You have to mess with Java a little bit more. What can you do in Java? You know what, for Java, I think that since there is some differences, I'll go ahead and code in Java separately. Okay, so just follow on here with respect to the logic and everything, but then we'll do coding in Java as well. Okay, so we have read through this. Now we are ready for processing. Remember, we said we have to attack it from all the sides, really, right? So, and from each side we have to specify which location, right? Which location we are starting and which direction. Okay. So, and what happens when you reach that? There's a mapping, right? You have the direction and the mirror position, and there's a mapping too. So how to handle all that? Okay. I'm going to use one C++ fancy mechanism. You don't even need the name, I think, but let's see. Right 0, left 1. You don't even need to say 1. It automatically assigns 1, up and down. What this is really a fancy way of this is another comment problem. Okay. Fancy way to assign constants values. Right? So it's basically this assigns right as 0, left as 1, up as 2, down as 3. Okay, you can assign some other values too. I don't think this is in Java, by the way. So we'll worry about it when you go to Java. We'll do something. So I think final, I guess, final int, something that I can mention. Okay, so back to C++. So now we have right, left, up, down defined, This will be useful at some point to define the mappings and stuff. So we need some functions, we want to utilize some functions. So remember, the idea is to do the maximum number of reflections. Remember that, right? Maximum reflections, if you want to call it, or maximum depth. Okay. Maximum reflections. Okay. Okay. So then let's have another find number of reflections. Find a number of reflections starting from particular position, row, column, and what? And the direction, right? And the direction. Okay. So we want our goal here is this is confusing me. Let's see. Let me fix that thing. Syntax highlighting, comment line, right? Default. Okay, that will take care of it. Okay. Starting from position r, c, row and column in direction, in the specified direction, compute number of reflections encountered, right? Number of reflection encountered before light goes out of the area. Okay. Okay. So okay, sorry for the interruption. Okay, let's keep going. Find lights go out of the area, and then compare with the max and update. Compare with the maximum number of reflection, update if needed. Okay, so that's what's going to do. That's why this is a void. We do everything here, and maybe just a count for now. Okay, then finally we check against the max reflection, update it. Okay, so now that we wrote it, we are kind of doing top down, by the way. You can see for each row, what are we going to do for each row? We are going to invoke find number of reflections, right? Find number of reflections, row position I, column 0, and we are going to go right. And another one would be the from the end, row I, m minus 1, right? The rightmost. Look at the picture. So we want to do from like this, test like this. Each position I want to test, then we want to test each of them like that. Okay, so that's what we are doing here. This should be left, obviously. Let's put the brackets here. Then each column I equal to 0, I less than m, I plus plus, 0th row, ith column, down, right? And n minus 1 row, last row, and ith column, up. Okay. So we have tested the area from all directions, right? So that one is covering here. Okay, very good. Now at this point we should have the answer, right? F out maximum reflections. We haven't done any the core logic yet. Okay, that's okay, we'll get there. So the challenge here, or the core piece, is to do the mapping where we are reaching, which direction we are hitting, right? Direction of light and mirror position, and that results in the direction, right? So for example, right and mirror position, this means down, right? Right will come and hit this and go down, right? So right up. So like this, you have to do all this stuff. Left, it's kind of hit from the left down, right? I don't want to confuse you too much, so let's say left, that's up. Left, you're hitting from towards left, right? So it hits here and goes up, right? Left, down. Okay, so then up like this means up, means left, right? Up, it hits that mirror, goes left. Up. We can handle this programmatically. Down, right, down, like that will be down, will be left, right? It just hits the thing. Hopefully this is clear to you, right? Right, from right side you're coming and hitting the mirror, it will go down, the light will go down. Right, hitting this mirror, it will go up. Left means you're coming from this side. Okay, I know it's a little bit confusing there. It's coming from towards left, right? So you're starting here, hitting this mirror, goes up. So hits this mirror, goes down. Up, we are coming up, hits this mirror, it goes left. Coming up, the signal light coming up, hitting this mirror, goes right, and going down, coming down, hits that thing right, coming down, hits this mirror, turns left. Okay, so we can code this one. Okay, that's one way to handle that. Another way to handle is using an array. In this one you can code it, right? For example, what can you do? Integer find direction, or find target direction, or find turn. What do we want to say? Target direction, integer, the input direction. What happened? Direction, and the character mirror position, right? So this can return, what is it's going to return? The direction it's going to return. So we can just code this as it is. How will you code this? Well, just a bunch of if statements, I think. If direction equal to right, then inside if position is equal to equal to like this. By the way, we need double one, okay, because less than is kind of that backslash is a escape character, so we need one more, okay. Maybe same in Java. Return what? Down. Else we know position is the other one. Really, there's not a big difference. Up. So then another else. This else is for this if condition. So do the same thing. So you can see this is kind of messy. If you want to do the other way around, you can do, because this slash is a bit easier. Anyway, I wrote it like this. I'll leave it as it is. What is this? Down and up and up and down. So reverse, right? So that's what I meant by programmatic. You write it as a program. Okay. If direction is, whoa, that's not right. If the direction is right, else if, we have to check that. Else if direction is left, right? Yeah. Well, we don't need a else really, because both cases we are returning, right? So direction is left, we do that. Direction is up and down next. Up and hit this, up, left, right, and the next one. We don't need that if check, to be honest, because we know exactly only one left is the down at this point. Down, right, and left. Okay. Okay. So target direction. Find target direction. So now we can do that right away. So how can we find the target direction? Well, you have the direction, target direction. We have the direction, and we need the mirror positions, mirrors of row, comma, column. See, that will give you the target direction, right? So what we want to do is, let's write some pseudocode, okay? While current position is valid, right? Current position is valid. Increment the count, right? Increment the count and update the direction. So that's update the direction. Given the update direction, and also adjust R and C, adjust row and adjust position too. So that will be updating the direction. That's that one. And adjust position, I'll come to that soon. Okay. What do I mean by this? While current position is valid. How do you do that? While row is greater than or equal to 0, row is less than n, row column is greater than or equal to 0, column is less than or equal to m, right? Okay, then we update the count, update the direction, then we check, do we adjust the position now? Yeah, okay. So because we came in the current position, we are hitting that and we will change the direction. Based on the direction change, we need to update where we are moving, right? See, once, let's say this one for example, right? We come here as 0 1, right? So as change the direction, you go here, it should become 0 comma 2. Current position column is 2, so that's what I mean. So if direction is right, current position column plus plus, else if direction is left, column minus minus, else if direction is up, row minus minus, else row plus plus. I'm going to short circuit there because that's the only remaining option. Okay, so do this, and current position is valid, and increment the number of reflections. That's nothing but increment the number of reflections. Are you missing anything? Is it possible to get the reflections get stuck? I thought about it little bit, for example, if you have mirrors like this, or let's see, I cannot think of a good way. So we know that here the reflections will get stuck, but the thing is, how it will enter, right? We know this will be infinite recursion, infinite reflections, but how will enter though? There's no magic way to enter, see. So it kind of gives me an idea, probably that's not possible. So I'm just going to ignore that case and see what happens. Okay, if you do want to worry about it, you want to take care of it, it's pretty simple. You can simply check count, see whether count goes above n into m. See, anytime it gets stuck in this type of thing, the count will keep increasing, right? When the count keeps increasing, goes above n into m, then you know that it is stuck inside, and then you can reset it to -1 or something they talk about. Okay, or you can adjust that later. Okay, so anyway, I'm not going to worry about all that. So the while loop is over. At this point, the number of reflections is over. So I'm just going to do max reflections is less than count, then max reflections equal to count. Okay, think we are done, is it? Yeah, let's compile. Looks like we are in business. Okay, let's go upload it and see what happens. Crashed. Okay, so I have some local file. Let me try that. Yeah, there is the local file. So let me try that one. Locally, and let's go ahead and put the C out here. 0. Okay, that's a problem. There's 13. Okay, very quick and dirty debugging. N and M, that's what I meant. Zero, 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 zero. Okay, it's not reading. Mirrors dot in, mirrors dot out. If in, what am I doing wrong? Is it a mirror? Is that what it was? Mirror, okay. Yeah. Okay, so back to the original code. I think that will work. And silly errors. Okay, let's go ahead and submit it in and see what happens. C++. Probably I should call this mirror too. So of course remember, C++ doesn't really care about the file name. Okay, there you have it. So back to the code. Let me explain. We just kept everything as a global variable, and we define this enumerated data type. It's not needed. You can do very simply something like this as well. It's just a fancy one-line version. Okay. Actually, I promise that I'll show something different too, right? So that's a equivalent one. Okay. So then we had a maximum variable, and this is the mapping. We try to do this target. We separate a function for a target, finding the target direction, and then we use a separate function to utilize to dig in to find the number of reflections, and then update the maximum number of reflection needed. In the main, we were just reading the stuff and then simply invoking from all directions of the matrix, right? Is it a matrix? All n into m matrix. We hit that matrix from all directions, up, down, left and right. Okay, I wanted to attempt to attempt something here. Let's see. So here it's a 4 into 2, right? 4 into 2. So what I can do is target like this. So I can try to kind of hard code it. Down, up, up, down, left, right, right, left. So that's basically array version of whatever the mapping here. Now how I can use this is how can I use this? And index of character. I'll explain in a second. 1 minute. Okay. So what this does is that it maps the individual character to 0 or 1. So the individual character, the slash means 0, other slash, back slash means 0, or forward slash means 1. So now that we have this, we can do So we can replace this target direction completely. How will you do that? So instead of this line, so what I can do is direction target. I can use target, right, the original direction, index of How does all this work? Well, it's a two-dimensional array, right? We know the direction. Direction is there mapped to 0, 1, 2, 3, right? 0, 1, 2, 0, 1, 2, 3, right? And we are mapping backslash and forward slash to 0 and 1. So we are using that as a second index to access this two-dimensional array. If you want to you're not required to do this way, okay? I'm just showing, okay? So you're basically directly accessing the array instead of doing this big program, okay? Lot of statements, little bit cryptic, right? But it's your choice, really, so because we have to really understand what's going on here when you write this. This is understandable and this is understandable. This one you have to be a little bit more careful, right? So this is for left, and this whole line is for left, and the backslash it goes down, and right regular slash comes up, so on. So the same approach for rest of the ones. Okay, so let's see whether this works. Okay, so by putting in the array we reduce the code. Okay, the slash mapping we needed that one because you cannot use the slash as directly as the index. See, so okay, sometimes you see this too. Okay, so looks like that works as well. Okay, so again, really up to you. Okay, if you with some careful thought you can come up with this, and this hash define. What does this do? Hash define. This is C mechanism. The character, whatever character you are giving, here it's converting to index. Okay, you can write this as a function too, but this I wrote it like a macro. So whenever you do the hash, it's a macro. So it's just kind of inline. It works like a function, but it basically replaces whatever code I write with that code. Okay, here. Okay, that's all. Thanks.